Hello, my name is Nur ZAIM AIZAT bin Nur ZAINUDIN from 2BMMM12. Today we are going to present about the torsional load of road cookie mold press. Okay, for the introduction, torsion is the application of a twisting or turning force to an object. This twisting force most often involves movement in one direction at one end of an object and stability of movement in the opposite direction at the other end. Torsional loading is a test that twists material or test component to a specified degree with a specified force or until the material fails in torsion. The twisting force of a torsion test is applied. The rotating movement may also be applied to both ends at the sample, but the end must be rotated in opposite direction. For the objective, to determine the behavior of a material or test sample exhibit when twisted or under torsional forces, to determine the modulus of elasticity in shear, yield strength, torsional fatigue life, ductility, ultimate shear stress, and modulus of rupture in shear. Check the product's quality and design to ensure that it was manufactured correctly.
Hello, my name is Cornelius. My part is about the conclusion of this project. So the mechanism that we choose for this project is the cookies press mold. From this box, it stated the rod is made of aluminum alloy. But before go further, I would like to explain how this mechanism functions. So, assume this is the rod A with diameter of 0.012 meter and length of 0.11 meter. Rod A acts as the rod that press the cookies out from the mold. And assume this is the lever with length of 0.08 meter. So we apply the force here, and the rod will be rotated. But when we continue apply the force here, even the rod is up to its limit, actually the rod will experience the torsional load. So hopefully this explanation be could clear for this how the mechanism function. So for the conclusion, first we need to find the polar moment of inertia. The polar moment of inertia could be solved by using this formula, where the formula is used is pi over 2 times by c to the power 4. So the final answer for the polar moment is 2.036 times by 10 power of negative 9. Next is we need to find the maximum shear stress. The maximum shear stress we solve by using the formula tau equal to Tc over J. So the final answer for the maximum shear stress is 9 kilonewton meter. Last, we need to find the resultant torsional force. So we assume all the moment that follow the clockwise is positive. So as you can see that where the negative 9 kilonewton plus F times by 0.08, so the final torsional force is 112.5 kilonewton. So the last part of the conclusion, we need to find the factor of the safety. First, we need to find the area. As you can see that the answer of the area is 1.131 times by 10 to the power of negative 4. So next, we need to find the allowable shear stress. The formula that we use is force over area. So the allowable shear stress is 994.7 megapascal. So for the factor of the safety, the formula that we use is fail shear stress over allowable shear stress. So the final answer is 27.14. For this project is clearly still safe even we apply for certain amount of the force. So that's all for me. Thank you.
Hi, my name is Ahmad Farid bin Abusman. I'm here to talk about the discussion and conclusion. For the discussion, the relationship of torque and shear stress was shown as follows. The equation is tau equal to rho t over j. This is denoted as the cross-section second moment region polar. That is often referred to as the second inertia moment. Second moment of inertia is known as the area measured the ability of beam to withstand bending. The greater the moment of inertia, the less the bend of the beam, where the mathematical equation can be followed from this equation, where y is the distance between the x-axis and the infinitesimal area dA, and x is the distance between the y and infinitesimal area dA. It's well established concerning object dynamic motion. Simple circular cross section from here, from this equation. Here we can distribute it is as T is the torque applied, L is the length of the beam, and G is material's rigid modulus, which is shear modulus, and J is the torsional constant. And finally, the safety factor is proven by this formula. Factor of safety equal to tau maximum over tau allowance. For the conclusion, following the method that been studied, we can infer that this project measurement and methodology is focused on teaching learning outcome, where we can apply our knowledge of how to measure torque, stress, torsion, and overall yield stress as follows. From this project, we can conclude the relation between the twist angle at any point along the rod and the shear strain inside the rod. We can relate the strain to the stress inside by using the Hooke's law. In conclude, our mini project conclusion relate to the theory of Hooke's law. As shown, the maximum force of the shaft tend to break, able to calculate, and also the way of the working of being called the free body diagram, shown how to apply the moment and the force to the tool that are being examined. That's all from me. Thank you.